Will be for the con assignment function domain word problems. So for domain, that means we're dealing with the possible x values. All right. So that's the definition for domain. And if you remember the formula for the linear equation, that's going to be y equals mx plus b. Okay, but as you get more advanced into algebra, you'll see instead of y, they will write it as f of x equals mx plus b. Okay, so that f of x, that just means function of x. All right, that means the equation depends on x, or what you plug in for x. All right, so it's not always going to be f of x. For instance, in the first problem here, they write the equation in the form of b of n. Okay, so the variable that's in the parentheses, that's always going to be your x value. All right, so since the domain deals with the possible x values, we're looking at the variable that's in the parentheses. And for the domain, we want to get the possible values for that variable. All right. So that's how all these problems are going to be. We want the possible values for the variable in parentheses. All right. So the house numbers on a certain street can go from 1 to 88. The function b of n models the type of building whose number is n according to the following key. Okay. So if it's a residential building, it's a 0. If it's a commercial, it's 1, and so on. All right. Which number type is more appropriate for the domain of B? So we're looking for domain. All right. So we're looking for the possible values for n. And let me see here. Okay, so this chart says function output. So the input is going to be n, and the output is b. So we don't really have to worry about the output here, because we're dealing with domain. That's the input, or the x values. In this case, it's the n values. And n represents the building whose number is n. It represents the house numbers. All right. So the domain is going to be from 1 to 88. All right. I'll answer the second question first. The domain n is going to be from 1 to 88, because those are the house numbers. We don't have a house number of 0, so it's not that. All right. It's going to be answer A. But for the first question, if it's integers, these are going to be discrete numbers. All right. So that means no fractions or decimals. All right. And if it's real numbers, the numbers are going to be continuous. Okay, so for the integers, it's going to have to be something like -4, -3, 1, 2, all right? They're discrete numbers with no fractions or decimals. But if it's a real number, it could be anything in between those numbers. So it could be 2, it could be 1.5, it could be 1.43, and so on. All right. So in this case here, n is the house numbers, and they go from 1 to 88. Okay, house numbers don't have fractions or decimals, so it's going to be answer A. All right. So all the problems are basically the same. All right. So and so's plant began sprouting 2 days before she bought it, and she had it for 98 days until it died. At its tallest, the plant was 30 centimeters tall. H of T models the height in centimeters, T days after she bought it. Okay, so the variable in the parentheses is your X variable. All right, so the domain is the possible values for T. So the plant began sprouting 2 days before she bought it, and she had it for 98 days. But T is the number of days after she bought it. All right, so 2 days before she bought it, that's going to be a -2. And she had it for a total of 98 days. So it's going to go from -2 to 96. All right, since she had it for 98 days, if we do 96 minus -2, that's a 98. All right, so the domain is going to be from -2 to 96. And T is the number of days after she bought it. Okay, now can you have half a day or a quarter of a day? Yes, you can. All right, days are continuous, so that's going to be real numbers because we're looking at the values for T, which is the number of days. Okay, so those are going to be real numbers, not integers, and it runs from -2 to 96. So for T, oh, okay, I made a small mistake. She had it for 98 days. All right. So I made a small mistake. It starts at -2 because that was 2 days before she bought it, but she had it for 98 days. Okay, so there you go. It's from -2 to 98. All right, one more. H of Y models the leading number of home runs for season Y of the National League between 2000 and 2010 according to the table. Okay, so let's see. H of Y is the number of home runs for season Y of the National League from 2000 to 2010. All right, Y is the season. All right, the Y represents years. So Y is going to go from 2000 to 2010. All right, that's going to be our domain. And the season, it's not going to have decimals or fractions. All right, you're not going to have year number 2000.6. All right, it doesn't work that way. So the season is discrete numbers. You count one at a time. There's no fractions or no decimals. So the domain is from 2000 to 2010, and there's no fractions or decimals, so those are going to be integers. All right. Those are going to be integers because real numbers have fractions and decimals, but these years don't have that. And the years go from 2000 to 2010.